coronal mass ejection strikes, or does it? Additional coronal mass ejections headed our way. Let's get into it. Here's the sun from the Solar Dynamics Observatory. This coronal mass ejection up here included some ejecta headed toward Earth. At least part of that once again expected to strike. Did we already see a coronal mass ejection strike late yesterday? We'll get to it. Some active regions rising. That's not a sunspot, by the way. The most likely place to see a major solar flare, in my opinion, is from sunspot 2877, which is this active region right here. The umbrae have been spreading apart. We'll show you that in a moment. First, the view from Lagrange point 1 to take a look at that coronal mass ejection that occurred right around midnight. And it's a bit stealthy. We don't have good data from stereo A yet. So stereo A is located out here at Lagrange point 5. We don't have good data from that yet. But from Lagrange point 1, we can see some ejecta here showing up on both sides of the obscurement disk. An indication that another rather diffuse coronal mass ejection is headed in Earth's toward Earth's vicinity. It's likely to strike Earth in about 3.5 days. You may not be able to see it, but I assure you, it is indeed there. So here you can see this. It's going to come out of this area right here. 304 angstroms is a great wavelength to show filaments, and you can see part of that does collapse back down, and part of it heads out into the greater solar system. We may make another video later today when the stereo A imagery, if it ever comes out, comes out. So here's the colorized magnetogram, and what I'm talking about here, this area right here, sunspot 2877, you can see these umbrae are spreading apart. And that is often the predecessor to major flares. So also as it approaches the limb, it's more statistically likely to produce large flares like M or X-class flares. Sunspot 2880, as it moves into the Earth-facing portion of the solar disk, less likely to produce major flares, at least less likely to produce major flares detectable at Earth. I won't get into the physics of that in the Daily Space Weather video either. We've got to do another video about that, perhaps with Mr. Bagashov. The radio flux has briefly gone up over 100, and now it's back to 95, I believe. Here's the one-year chart of the radio flux, the most proportional data set to sunspot number, and you can see it's getting a little bit spiky here. The black line's the radio flux, the red line, the sunspot number. Space Weather Enthusiast dashboard. Yeah, so radio flux currently at 95, and the NOAA forecast is for geomagnetic activity to calm down now. So it looks to me, well, I'll get to it when we get to the solar wind data. Let's continue on here to talk seismicity for a brief moment. There have been some earthquakes, no major ones. There was a deep quake at Bolivia, a 4.5 at 233 kilometers estimated depth. Also a deep quake at Vanuatu. That was one of the largest of the past 24. It's a 5.1 at just over 170 kilometers. Deep quake at Afghanistan, also a 4.8. Fiji Island saw a deep quake. Chile saw a deep quake. So lots of deep quakes there, folks. The Aleutian Islands also saw a 5.1. Another deep quake at Peru. So significant deep quake activity there. There's another deep quake at Argentina. The Geysers, California saw a quake 100 meters above sea level. It was a 2.8 magnitude. Let's just briefly zoom in on the U.S. here. There's where the latest quakes have been happening in the U.S. And let's talk volcanoes. Check it out. Here's Kilauea's new lava lake. New lava lake here at Kilauea, the Hawaiian volcano. And here's some of the lava fountaining and lava cone-shaped features coming out of La Palma, the Canary Islands volcano. Let's see what else is on the list. So yeah, La Palma, This is an uptick since yesterday. It's producing a 14,000-foot plume of volcanic ash. So stable lava output, several lava flows, both near the vent. Southerly winds causing ash flow around El Paso. That's not Texas, that's in the Canary Islands. So driving becoming difficult there. And lava fountaining between 50 and 100 meters continue at the Fisher Vent on the northwest lower flank, while several vents in the summit, as well as two newly formed vents in between, were producing pulsating, powerful, and near vertical jets of gas, ash, and lava bombs. Don't be under a lava bomb. So perhaps the situation getting more extreme there at La Palma. We'll keep an eye on it. Suwanosejima exploding as well, 11,000-foot ash plume there. Luatolo now back on the list, 8,000-foot ash plume over the Lesa Sunda Islands as it explodes. Again, Kilauea has recently produced another lava lake. And it's not at Pu'u'o'o, it's at Halema Uma'u crater, part of the Kilauea complex. The volcano reached a breaking point, suddenly expressing a quick rise in ground tilt along with a swarm of earthquakes. So some magma reorientation going on there. Popocatépetl exploding, 19,000-foot ash plume over central Mexico. Sangay exploding, 22,000-foot ash plume over Ecuador. Revenador, the same country, 15,000-foot ash plume from Revenador. Is a reminder to not pole vault the caldera. Do visit our links, support the channel. Click the links below the video. Head to smashamash.com. You can find links to this stuff there. Our merch links include all of that. Today's featured product is Mensa. Make Earth not suck again. Since it's up to you, not giant heaving bureaucracies that can't get out of their own way. I'm currently wearing the hat because I understand my role in making Earth not suck again. So we encourage you to do the same. Maybe pick up some merch and tell your friends and foes to do the same by wearing a hat or a shirt. Thanks to everybody who did pick up merch. It's a great deal of help for us, as we're paid just this side of nothing by YouTube to make the content. So again, please support the channel financially via the links below the video. We're also on BitChute. Did you see our most recent exclusive? Wearing a mask in public, go home, you're sick. And of course, thanks to our YouTube viewers. Don't forget to press like and subscribe if you enjoy the content. Press share. The algorithms don't seem to be particularly friendly to our channel. So welcome to SMASHTOBER. No more no more ability to speak English. No more sneak peeks for YouTube viewers. We're going, quote, dark, end quote, for the entire month of SMASHTOBER, which means you'll see no difference since you're a member of the Smash team. But those of you who aren't members of the Smash team, you'll see nothing except a message like this. Since we can't provide the services that we do for free, so thanks to our silver and gold members. Bronze members, consider upgrading. You'll see all kinds of other posts that you're not able to currently see. And thanks to everybody who's continuing to allow our operations to proceed, namely Smash Team Silver, Gold, and paid-up annual gold members who get complimentary merch, by the way, and a free month figured into their pricing. If you head to smashamash.com, you'll find our links there. SMASHO merch and the Smash team are the ones we've just been talking about. We're also regularly live streaming on Twitch, twitch.tv/SmashaMatch. Thanks to our new subscribers over there. Let's get back to space weather data, looking at magnetometer stuff. And check it out. We're seeing some very low readings here on the magnetometer, making it all the way down to like 30 nanotesla there, at least as measured by the GOES 17. Maybe not quite that low. Anyway, seeing some big spikes in there in the magnetometer as well, as this is when a bunch of plasma arrived, folks. A bunch of plasma arrived at this moment. We saw the solar wind density make it up to about 40 protons per cubic centimeter. Let's take a look at some more magnetic stuff before we look at things like the real-time solar wind. Here's the top view ecliptic plane field plot. And Earth is in a strong-looking North Pole oriented current sheet. which is frankly kind of surprising. But there you have the data. It's part of the National Sunspot Observatory. And here's the line of sight ecliptic plane field plot. I think we may see some activity rising in the southeast based on the magnetic data. Here's your coronal hole plot. And we see a lot of, we see some trans-equatorial North Pole-oriented coronal holes now. Check it out, folks. We've got some North Pole coronal holes rising in the east. And I think some activity rising in the southeast as well. We'll keep you posted on that. Here's the best visualization of coronal holes. So we've got some North Pole ones rotating in and some South Pole-oriented ones already in the Earth-facing zone here. So a bunch of activity kicking up. Again, the most likely place to see a major flare at the moment is Sunspot 2877, less so with 2880. They've both remained largely stable, although the umbrae from 2877 have spread apart, which is something we typically see before solar flares. Anyway, coronal mass ejection warning and solar flare warning continue. No major flares over the past 24 hours. Just a small C-class intensification there. No spikes in the proton flux. At least not since September 28th. And that was pretty minor. So here's the real-time solar wind. And indeed, if this is the coronal mass ejection strike that we were forecasting, it came at the same time as a coronal hole wind stream arrived. So this is the thing that can certainly happen, folks. The solar wind density made it up to about 40 protons per cubic centimeter at that moment. And then we saw the density subside and the velocity come up to quite high levels here. So based on this ongoing trend of high velocity solar wind, which we're actually seeing continue to this moment, current conditions are 543 kilometers per second. That's a significant enhancement of background solar wind. Some of these little spikes in here do look like small coronal mass ejection hits. You can see this signal in the temperature down here, coinciding with upticks in the density and the speed. So basically what's happening here, folks, is the coronal hole wind stream is overshadowing the coronal mass ejection, which is looking quite diffuse here. So a couple minor spikes there within the coronal hole wind stream, sort of masking the effects. Anyway, current conditions are 13.89 protons per cubic centimeter for the solar wind density, solar wind speed 543. The BZ has just dropped into negative territory, so we may go back into geomagnetic unrest or geomagnetic storm conditions, and there may be additional pulses still striking. It's difficult to calculate the velocity of a coronal mass ejection. Trajectory a little bit easier. We'll be working on that in the future on the channel as well. So here's the KP index, and it only ever made it up to a KP4 geomagnetic unrest condition. Again, don't be surprised to see this go back into geomagnetic unrest here with that shifting of the BZ into the negative territory. If it stays negative for a significant period of time during a coronal hole wind stream like this, we'll go back into geomagnetic unrest. That's my forecast. Here's the geospace of the past 4 hours as modeled by the Space Weather Modeling Framework. If you want to read about that, go to the Geospace Magnetosphere movie, click on Details, and click on Space Weather Modeling Framework. You'll find a link there. And here we can see some little striations here. Those are likely bits of coronal mass ejection coming in within the coronal hole wind stream. And we regularly see strong coronal hole wind streams masking coronal mass ejection strikes. That's 4 hours of magnetohydrodynamic pressure data. Here are ground magnetic perturbations. Since we are currently in a geomagnetic excursion, we show this daily. Perhaps it gives us insight into the underlying magnetic structures that make the Earth the Earth. We see pulses coming out of the Pacific Ocean and so on. Keep in mind this is in nanotesla. And there you see a significant intensification there. And let's actually check the aurora forecast. So that ground magnetic perturbation map gives us great insight into where we're likely to see auroras. Also, where are the most likely places to see things like spikes in induced power and power systems. And our regular viewers are probably well aware that geomagnetic storms can cause damage to power grids, yes. Now, in most modern nations, the transformers know when to shut down to prevent themselves being damaged. And there you can see a little intensification of the aurorae there, coinciding with the time of those ground magnetic perturbations. Here's where stuff is in the solar system, and we're about to lose contact with some Mars rovers as there is an Earth-Sun-Mars conjunction happening. Let's advance this 1 week. Here's where things will be in a week. Don't forget to wish Smash staff a happy birthday on October 6th. Next, a star chart. This is what's going on above my head. We're located in Lehigh Valley, Pennsylvania. The yellow line is the ecliptic plane. The blue line is the galactic plane. Continuing on to today's cosmology segment, which will be integrated into the daily space weather video. So we've got over 200 cosmology segments on playlists that are separate videos, and we regularly dovetail cosmology segments into our daily space weather videos because there's a lot of stuff to talk about when it comes to things space, and we're doing it. So first of all, it's the astronomy picture of the day. This is a highly complex molecular nebula located at only 450 light years distance. And it's got various different objects in it here. This includes M20, Messier catalog number 20, as well as NGC 6559 at the far left. It's a quite rich area. There are also some background objects there as you're looking partially through this. And they say it looks like a... Somebody's claiming that it looks like a bowl and pipe or something. I have no idea what they're talking about. I just see some emission and some absorption features in this complex molecular cloud. You can go look at it yourself, if you like, at apod.nasa.gov. So here's the Earth-Mars transition that we're talking about. You can read about it on SciTech Daily. What happens when the sun blocks our signal? I'm not going to really worry about it too much. Those rovers will be incommunicado as a result of that. And here you can actually see Mars moving in behind the LASCO C3. So we brought up a custom Soho movie here just for your viewing pleasure. And you can see multiple coronal mass ejections here, including one late in the day yesterday. Again, we expect a minor glancing blow, sort of a barely detectable diffuse event from this most recent coronal mass ejection. Today's random number is 923, which will coincide with some object. It's a quasar. And if you go to the Neil Gehrels Swift Observatory, number 923 is this quasar here, B2005 plus 40. And these are the hard X-ray outputs from that galactic nucleus. We'll talk more about quasars in a moment. First, let's take a look at this visually. So here it is on the DSS-2 colored. And you can see that dim object there is probably quite distant. That is actually an active galactic nucleus. Believe it or not, folks. So scrolling down the list here, let's check Pan-STARRS. And there's a little better view of it on Pan-STARRS. It's a galaxy, not a star. And back in the mid-90s, we didn't even know what quasars were. Does it show up on the SDSS-9? Indeed it does. Perhaps some added resolution there. And how about the 2-mass? And there are the thermal spectra of that quasar. Quasar B2005 plus 40. Entry number 923 on the Neil Gehrels Swift Bat X-ray Observatory. So quasars are a specific type of active galactic nucleus where the viewer is located in this jet. In other words, you're viewing it from a perspective like this. Now, if you were viewing it directly in the jet, it would be considered a blazar. Somewhat within the jet is considered a quasar. If you're viewing a galaxy edge on, such as from this perspective, you know, you're over here viewing the edge of the disk, it's typically going to be a radio galaxy. It's all about perspective, folks. All about perspective, and that's today's cosmology segment. Hopefully it gave you some. and it certainly wouldn't have convinced you of any nonsense. Moving on to charging hazards, and we see some surface charging hazards here around the Caribbean and Mexico, Central America. So that could cause some communications failures. It could cause some data loss, and it could cause people to think that Nibiru has crossed in between the Earth and the GOES 16. Next, looking at the relativistic electrons here on Solon.info. You can see we're just in a moderate range. We briefly reached warning levels yesterday. I think I might have forecasted that, but in any case, there is the electron flux. We're expecting this to remain cratered here until the coronal hole wind stream subsides. And it's a significant coronal hole wind stream with speeds of over 500 kilometers per second. I would say this is going to be a little bit lower tomorrow. That's the electron forecast from NOAA. Again, mine is a little bit lower than their green box someplace down here. Next, a diagram of Earth's Van Allen belts. Distances are shown in miles. Feel free to pause the video if you need to look at what this is showing. Now we're showing the total electron content forecast. And we'll see if we see any chaos happening here in the electron belts. Something more common when we see coronal hole wind streams. Everything looking fairly organized at the moment there in the total electron content forecast. Next, we're going to show you the ionosphere layer located at about 300 kilometers of altitude. Here is the ionogram of the past day. It's showing 2 hours per each second, and it's showing vibrational frequency in megahertz, millions of vibrations per second. Mainly high-frequency anomalies at the moment. Here's the anomaly map showing you departure from the 30-day median in megahertz. Some pretty wild swings there in the ionosphere, with some low-frequency and high-frequency anomalies close by to each other. There's the latest image from 9 o'clock Universal Time. There's the ionogram, and there's the anomaly map. You can see primarily high-frequency anomalies shown in blue. All right, let's do bonus features. Did you see our meteorology segment? It's pretty good. First bonus feature is the El Teide ground-based solar observatory. So here's the latest imagery from El Teide, Spain. Once again, I would remind you the most likely place to see a major flare is from Sunspot 2877, as Sunspot 2880 is moving into the Earth-facing quiet zone. Coronal mass ejection warning and solar flare warning remain in effect as we kick off the month of SMASHTOBER, and I might talk in a stilted voice for an extended period of time. Here's your latest intensity gram. And see how far apart those umbrae got in Sunspot 2877. It looks like 2880 has actually degraded in the past day. It's still certainly capable of producing major flares, but this is the area to keep an eye on the most. Again, there's another coronal mass ejection headed our way. Lots of stuff going on. We may have to make another video this afternoon. Once again, the coronal mass ejection warning and solar flare warning remain in effect. So there you can see that coronal mass ejection and filamentary collapse, actually. Both things happened up there in the northeast. And we'll close things out with some more imagery of that. So here's a great close-up in 304 and 171 angstroms of Sunspot 2880. Just spectacular. And here's a zoomed-out view of the northern hemisphere. Great view of that filamentary eruption, collapse, and coronal mass ejection. Thanks again for tuning in, folks. Don't forget to visit our links below the video. Tell your friends and foes about the channel, as the algorithms have been less than optimal. And may that solar wind be at your back.